let's find a deflection at node E of this truss. So that's where we apply our unit load, and therefore the external virtual work is the unit load by the deflection at E, and that's equal to the internal virtual work due to the deformation of the truss members. So we sum from I equals 1 to n members, and we have the virtual force in each member by the real force in each member by the length of each member on the axial stiffness, which we take outside the summation, assuming that all members have the same cross-sectional areas and the same Young's modulus. And now we construct the table. So for each member we have the length, the virtual force, the real force, and the product in this sum. So that'll be FIV by the real force by the length, and these have units of meters, kilonewtons in this case. The real force is also in kilonewtons, and therefore this product is in kilonewtons squared meters. And now we're going to list all the members in the table. So we have AE, BE, and so on. And we have the length of each member, and by geometry the diagonal members have a length of root 2. So all the members have a length of 1 except the diagonal members. And using the method of joints, I've worked out the forces in each member, which you can verify yourself. And I'll also write these in the table. And we can also use the method of joints to find the virtual forces in each member, where we've applied the virtual load at node E because that's where we want to find the deflection of the truss. So we can see that by horizontal equilibrium of joint D, we have the zero force members DF, and vertical force equilibrium gives the zero force member BD. And similarly at C, we also have zero force members, and vertical equilibrium of joint E gives us the tensile member, which has an internal virtual force equal to the virtual load. And we write this as a tension member just for convention, noting that the virtual load does not cause any deformations of the truss. And by symmetry you can find the reactions of the truss, so that will be equal to half the unit load of 0.5. And I'll leave it for you to take equilibrium of the other joints using the method of joints, and you'll be able to find the forces in the other members. So it'll be 0.5 tension, and by horizontal equilibrium we have the same force in member AE, which is tensile by convention. And the force in member AF is compressive, so 0.5 root 2 virtual in compression, and by symmetry we have the same force in member BF, which is also compressive. And now we can write the virtual forces in the table. Now if you evaluate this product, we have length by virtual force by real force, and I'll write the results in this column. And now if we sum these together and divide by the axial stiffness, we'll get the deflection at E, which is 1.5 plus 2 root 2 on AE. Please subscribe, like and comment to help me reach more students.